Okay, once again, good morning, good day, good afternoon throughout the world. This is your teacher, Castor Ayuban of Mathematics 10. So this time, we'll have quarter 3, module 3, lesson 1, week 3, and we have day 1. Today, I will teach you on how to find combination of an objects. And we have our competency illustrates the combination of an objects. Objectives. At the end of the lesson, you are expected to, number 1, illustrate combination of an objects. Number 2, find the number of combination of an objects. And we have number 3, solve problems involving combination of an objects. So what do you mean by permutation? Permutation refers to the arrangement of an objects in regards of their order. That is, changing the order of the objects create new combination. The arrangement is important. So this topic was our topic before this video. And we'll have a sort of combination refers to the selection of an objects regardless of their order. So regardless of their order. That is, changing the order of the objects does not create new combination. After changing the order of the objects, and the arrangement is not important. So the arrangement is not important, and that is combination. Combination is just the opposite of permutation. For instance, the 3 combinations of the letters F, B, and O taken 2 at a time are, we have FB, FO, and BO. FB and BF are considered as combination. Similarly, FO and OF and BO and OB are the same combinations. There is only one combination that can be made from the letter F, B, and O, taken 3 at a time. That is FBO, FOB, BFO, BOF, OFB, and OBF are considered one combination. So, this does not create new combination but considered as one combination. The combination of n things or objects taken are at a time can be denoted in different ways. We have C quantity n, comma r, plus quantity, or we have NCR, and those will be read as combination of n objects taken are at a time ways. In the first illustration, there are 3 things, letters FBO taken 2 at a time. So we have the formula, combination of 3 letters taken 2 letters at a time is equal to 3. In the second illustration, there are 3 things taken at 3 at a time. And we have the formula, combination of 3 letters taken 3 at a time is equal to 1. Anyway, I will give you a concrete example in our what's more. And take note, this is very important because this will be your referral. This will be the referral of your answers in what's more, quarter 3, module 3, lesson 1. We have one example. Miss Anna went to a grocery to buy the following: coffee, C, milk, M, sugar, S, and butter, B. Upon reaching the grocery, she found out that her money is not enough to buy any of these items. Again, I will read this problem to you. Miss Anna went to a grocery to buy the following: coffee, C, milk, M, sugar, S, and butter, B. Upon reaching the grocery, she found out that her money is not enough to buy any of these items. Question number 1. In how many ways can she select the 3 items? Number 2. List the possible selections. This time, I will give you the knowledge on permutation so that you can compare this to combination. We have in how many ways can she select the 3 items? We have the answer is we have permutation of n things taken at a time is equal to 24 possible ways. That is if the arrangement is important and we are talking to permutation. The number of possible selections or arrangement is important. And they are, we have, because permutation is all about arrangements, so we're going to arrange coffee, milk, and sugar. Let's say we are going to place this on the table. You have the arrangements of coffee, milk, and sugar. So the first arrangement is coffee, milk, sugar. Another arrangement is coffee, sugar, milk. Another we have milk, coffee, sugar. Then we have milk, sugar, coffee. And we have sugar, milk, coffee. And we have sugar, coffee, milk. So as you have seen in our arrangement, the arrangement is very important. So you have how many arrangement? You have 1, 2, 3, 4, 5, and 6 arrangements. We have now 6 arrangements. How about if we are going to arrange coffee, milk, and butter? This time, we are going to arrange coffee, milk, and sugar. We have first combination or arrangement. We have coffee, milk, butter. Then coffee, butter, milk. Then butter, coffee, milk. You have butter, milk, coffee, butter, and milk, butter, coffee. Again, we have 6 arrangements. So we have already 6 plus 6 is equal to 12 arrangements. And we are talking to permutation. The arrangement is very important. Now, we are going to arrange coffee, sugar, and butter. The arrangements are coffee, sugar, butter, coffee, butter, sugar, butter, coffee, sugar, butter, sugar, coffee, sugar, butter, coffee, and we have sugar, coffee, butter. And still we have 6 arrangements. How about if we are going to arrange coffee, milk, and butter? So we have the arrangements. Butter, milk, sugar, butter, sugar, milk, milk, sugar, butter, milk, butter, sugar, sugar, milk, butter, and we have sugar, butter, milk. Again, we have 6 arrangements. If we're going to sum up the arrangements, we have 24 arrangements. And that arrangement is important, so we are talking with permutation. We are talking with permutation. We are going to compare this to combination because the number of ways of the permutation and combination differ. So, again, because the arrangement is important, so we have now permutation of 4 objects taken 3 objects at a time is equal to 24 ways. So we have already illustrated before that in every arrangement, there are 6 ways of arrangement of this given problem. So the total number of permutations or arrangement is equal to 24 ways. And again, arrangements of objects is important. So again, we are talking with permutation. So that was our lesson before this video. We have solution. Still, we are in permutation, where n is equal to 4 and r equals 3. So we are going to substitute n equals 4, r equals 3 of the formula permutation of n objects taken r at a time is equal to n factorial over quantity n minus r factorial. We have now n is equal to 4 and r equals 3. So this will be equal to 4 factorial divided by 4 minus 3 quantity factorial. And this will be equal to 4 times 3 times 2 times 1 factorial all over 4 minus 3 is equal to 1 factorial. So you are going to cancel 1 factorial over 1 factorial. So the remaining numbers are 4 times 3 times 2 times 1 is equal to 24 over 1 factorial is equal to 1. So you have 24 divided by 1 is equal to 24 ways. Is it understood? So that was permutation. But how about combination? How will you get the answer of that given problem if we are going to use combination? The number of possible selections, combinations, or arrangements is not important. So I will give you these 6 circles and let the circles be glasses. So we are going to combine coffee, milk, and sugar. These are some of the arrangement of this. coffee, milk, and sugar. Now, if we are going to put coffee, milk, and sugar in a glass of hot water, so meant does not matter. In glass number 1, we are going to put coffee, milk, and sugar. So what will happen to the coffee, milk, and sugar putting in a glass? Again, the number of possible selections or combinations or arrangement, this means that the arrangement is not important. And they are, if we're going to put coffee, milk, and sugar according to the arrangement, referring to our solution and permutation, if we're going to put coffee, milk, and sugar in a glass, what will happen? So there is no arrangement anymore. Arrangement does not matter. The coffee, milk, and sugar is already combined. Then in glass number 2, we have coffee, sugar, and milk. Again, arrangement does not matter. In glass number 3, we have milk, coffee, and sugar. Again, the arrangement does not matter. In glass number 4, we have milk, sugar, and coffee. The arrangement is not important or does not matter. In glass number 5, we have sugar, milk, and coffee. So, the arrangement is not important. And number 6, we have sugar, coffee, and milk. Again, arrangement is not important or does not matter. So we have the arrangement of coffee, milk, sugar, coffee, sugar, milk, milk, coffee, sugar, milk, sugar, coffee, sugar, milk, coffee, and sugar, coffee, milk. Putting in glasses is just equal to one combination. So there is only one combination. Another, we have 6 glasses. And this time, we're going to put coffee, milk, and butter in the first glass. In the second glass, we have coffee, butter, milk. Third glass, butter, coffee, and milk. Fourth glass, butter, milk, and coffee. And fifth glass, milk, coffee, and butter. And sixth glass, we have milk, butter, and coffee. Again, the arrangement is not important. The order of the arrangement does not matter. So we have combination of coffee, milk, and butter, coffee, butter, milk, butter, coffee, milk, butter, milk, coffee, milk, coffee, butter, milk, butter, and coffee is just in one combination. Unlike in our permutation, there are 6 arrangements. But in this combination, there is only one. Only one way. So, only one combination. Let's try to put coffee, sugar, and butter in 6 glasses. In the first glass, we have coffee, sugar, and butter. Second glass, coffee, butter, and sugar. Third glass, butter, coffee, and sugar. Fourth glass, butter, sugar, and coffee. Fifth glass, sugar, butter, and coffee. And sixth glass, sugar, coffee, and butter. Again, the arrangement is not important. The arrangement does not matter. They are just in one combination. Next, we are going to put butter, milk, and sugar in 6 glasses. So first, we have butter, milk, and sugar for the first glass. Second glass, butter, sugar, and milk. Third glass, milk, sugar, and butter. Fourth glass, milk, butter, and sugar. Fifth glass, sugar, milk, and butter. And sixth glass, sugar, butter, and milk. Again, they are just in one combination. So, the number of possible selections or arrangement is not important. And thus, we have coffee, milk, and sugar is just one combination, putting in 6 glasses. Coffee, milk, and butter is just in one combination. Coffee, sugar, and butter is just one combination. And butter, milk, and sugar is just in one combination. Therefore, the combination of n things taken are at a time, or we have n is equal to 4 and r is equal to 3. So there are only 4 combinations. The combination or the arrangement is not important, or the order of the arrangement does not matter. That is, if the arrangement is not important, so we are talking with combination. Conclusion. N is equal to 4 and R is equal to 3. So we are now using the formula of combination of n objects taken r at a time is equal to n factorial over r factorial times quantity n minus r factorial. N is equal to 4 and r is equal to 3. So we have n factorial is equal to 4 factorial all over r factorial is 3 factorial. N is equal to 4 minus r is equal to 3. Then we have factorial. 4 factorial is 4 times 3 times 2 times 1 factorial all over 3 factorial. 4 minus 3 is equal to 1 factorial. So again, we have 4 times 3 times 2 times 1 factorial all over 3 factorial times 1 factorial. So we have now 4 times 3 times 2 times 1 is equal to 24 all over 3 factorial is 3 times 2 times 1, and we have 1 factorial is equal to 1. So we have now 24 over 3 times 2 times 1 times 1 is equal to 6. And we have now combination of 4 objects taken 3 at a time is equal to 4 selections. We have 24 divided by 6 is equal to 4. The arrangement is not important, so this is combination. Unlike with permutation, there are 24 arrangement because the arrangement is important. While in this combination, there are only 4 selections because the arrangement is not important. When you're going to put the 3 things in a glass, that is only 1 combination. Is it understood? So let's go to the answer for A1 and 2. A1 and 2. So how many possible selections? N1 and number 2, you are going to list the possible selections. We have the answer in A. We have 1. Combination of n things taken are at a time, or we have combination of 4 things taken 3 at a time is equal to 4 selections. And we have number 2, list of possible selections or combinations. So we have number 1, coffee, milk, sugar, coffee, sugar, milk, milk, coffee, sugar, milk, sugar, coffee, sugar, milk, coffee, sugar, coffee, milk is in 1 combination. We have coffee, milk, butter, coffee, butter, milk, butter, coffee, milk, butter, milk, coffee, milk, coffee, butter. We have milk, butter, and coffee. We have one combination. Coffee, sugar, butter, coffee, butter, sugar, butter, coffee, sugar, butter, sugar, coffee, sugar, butter, coffee, and we have sugar, coffee, butter is in one combination. And finally, we have butter, milk, sugar, butter, sugar, milk, milk, sugar, butter, milk, butter, sugar, sugar, milk, butter, sugar, butter, milk is in one combination. We have letter B. In situation letter A, what about selecting 2 items from sugar, milk, coffee, and butter? How many selections? That is from A. Miss Anna went to a grocery to buy the following coffee, milk, sugar, and butter. Upon reaching the grocery, she found out that her money is not enough to buy any of these items. Again, letter B. In situation letter A, what about selecting 2 items from sugar, milk, coffee, and butter? How many selections? So this time, I will give you the answer for letter B. We have now n is equal to 4 and r is equal to 2. Using the formula, we have combination of n objects taken r at a time is equal to n factorial over r factorial times quantity n minus r factorial. So n is equal to 4 and we have r is equal to 2. So we have n is equal to 4 minus r is equal to 2. So we have close quantity factorial is equal to 4 factorial is 4 times 3 times 2 times 1 factorial all over 2 factorial. Then 4 minus 2 is equal to 2 factorial. So we have again 4 times 3 times 2 times 1 factorial all over 2 factorial times 2 factorial. So this will be equal to 24 over 2 times 1 and another 2 factorial 2 times 1 is equal to 24 over 4. You have 2 times 1, 2. 2 times 1, 2. 2 times 2 is equal to 4. So we have 24 divided by 4 is equal to 6 selections. So we have combination of 4 objects taken 3 at a time. We are talking with the butter, coffee, milk, and sugar. There are only 6 selections. The arrangement is not important. So this is combination. That's the end of my lesson. To those who are not yet subscribing my YouTube channel, please subscribe now and please do not forget to hit the notification bell for some updates of my videos. Thank you for watching. For videos, please click here and subscribe my YouTube channel. Thanks for watching.